Hi, welcome to Hard-Boiled Synthesis, Lecture 2. After posting the first video, I was super excited to find out that my lecture got organized with many videos that try to show you how to cook eggs. And and that's just a little bit of silliness I did not anticipate. You know, I call the course hard-boiled synthesis because hard-boiled being practical, and that I'm not covering content per se of a meta-analysis. I'm trying to show you how to complete one from A to Z. Anyway, so today we're going to focus on screening. In the first lecture, we formulated keywords. We tried to find studies by searching Web of Science. And again, my goal is to synthesize studies that use catnip as a repellent to mosquitoes. And I think in the end, I found 240 some studies in Web of Science. And so today is just going to be the super boring task of screening those studies, reading the title, reading the abstract of each one of these studies to identify candidates that would be appropriate for meta-analysis. Again, I'm just looking for studies that are testing catnip as a repellent to mosquitoes. And just quickly going through a lot of the studies in the last lecture, many are not relevant, right? We got bed bugs and we had fruit flies. I'm going to focus on mosquitoes. And that's because originally I kept my search fairly broad. I just wanted to find catnip repellent studies, which is very inclusive, includes all sorts of taxa. And so now I'm going to narrow down that collection specifically to things that search for mosquitoes. A little bit of preamble, though, before getting started. I really do not want to start screening these things, but I have to do it. But while rewatching the first lecture, I noticed that there were some issues, and so maybe the best thing to start is to review our wall of shame, our wall of how we deviated from best practices, and then it'll give me a chance to correct some of these typos that I had in the list. I mean, I'm doing this on the fly, so nothing's going to be perfect, right? Just one take. That's the point of the class, so I could get this done. First thing that came up is, let me bring up the wall of shame. All right, is I meant scoping, not spoping. I mean, so I'll quickly fix that. Scoping. So two issues that came up was I really did not spend time to study the literature before beginning my search. That's a no-no. You need to really have a good idea for what you want, even before starting a project. I mean, if you're, say, for example, a graduate student and you're doing a dissertation chapter, man, read up on the topic a lot before you even begin doing the synthesis. You'll have a way better idea of what are the proper things that you should be searching for when you're doing one of these meta-analyses. Also, I kind of did a poor job formulating keywords. Again, I just went on a Wikipedia page and I pulled all the common names of catnip, which included catmint, which I think is quite the lovely name. Maybe it would be a great bubblegum flavor, catmint. I don't know. Anyway, but other violations of best practices, searching. Here's another one. Only searched one database. Let me fix that. Again, that's a no-no. You know, I call Web of Science a database. It's really just like a meta aggregator of many databases. But it's really just one source. And if you want to have a robust synthesis, you should try to include multiple sources of studies. Web of Science is not great for covering gray literature. Gray literature are just kind of like these odd-end studies that don't get a lot of attention. They may not have actually been published in a formal journal. They're probably locked into a dissertation or maybe just available as an abstract. And so it's important to try to be thorough and try to find all these things. I mean, the goal is to publish this, right? And to have an impact on the discipline, you should try to be robust and thorough. I'm cutting corners here because I'm teaching this class and I can't spend all my time being exhaustive. All right. And then finally, I poorly kept track of my database details. That's a Web of Science thing. I mean, Web of Science, again, meta-aggregator across multiple databases. It's not super easy to find which databases are searched, but if you remember, I cut and paste the list of studies, right? And my Word document, my working version of the manuscript, and I put them all over here. Okay, so the Web of Science Core Collection, which is in itself another collection of of databases, and then you have like citation indexes, a patent database, the Derwent Innovations Index. We got non-English language ones like Koreans and Russian Citation Index. Depending on where you are institutionally and what your library has access to, this list may actually differ. That's a real bummer, again, of Web of Science. It's a product, something that your library purchases or subscribes to. It's like I don't know what it is, a negotiated price with the company to have access to all these things. And so, yeah, it's going to vary a lot across universities, continentally, depending on where you are geographically. My guess is all this is kind of negotiated at the library level, where the library's like, I want access to Web of Science for the university, and then they negotiate a cost with the company. Anyway, where was I? So these were the violations of. Let me quickly go through here. I'm a bit lost. My wall of shame. Okay. Violations. So I've already kind of messed up a bunch of times. But the goal now for today is to make sense of what I downloaded from the Web of Science, which is just like a collection of bibliographic information based on my search for catnip and repellent. See effects. And so let's get started. I mean, we went through the search phase. Okay, that was what I call phase 2. And so let's look at some of the results already that we got from the Web of Science search. I already opened up the weird file that I downloaded in a last lecture in Excel. It's a tab delimited file. Let's have a quick look at it. Okay, it's this. It's like, thank you, Web of Science, for making this as clear as possible in what I'm downloading. I mean, there was a while where you could download from Web of Science and it would give you like a massive collection of columns, including number of citations and a whole bunch of maybe neat meta-science stuff. But for meta-analysis, it's just noise. It's really just noise. And there's still just a lot of noise in this vanilla thing that we downloaded, which when it prompted me, what I wanted to download was like, do you want the title? Do you want the authors? Do you want the abstract? Yes. Do I want all this other stuff that you've given me, Web of Science, like your own unique Web of Science number? I mean, no, I don't want any of that stuff. And so now I'm just going to spend time cleaning up this tab delimited file, convert it into a comma delimited file, which can be used in R. I'm basically going to be using R for the rest of the lecture. But I'm going to cut out all this nonsense, this noise from the Web of Science file. Basically, all I want is the authors, the title, the abstract, the volume, page numbers, DOI, digital object identifier, which would allow me to track the PDF of the study at some point, and the year of publication. And so I'm just going to quickly zip through and cut all this noise. I already know what these columns are, and I am not interested in any of this stuff. Volume, issue, don't need issue, page numbers, cool. I'm even going to ditch these digital page numbers. Publication year, abstract is really the really important part, and then everything else is just garbage. No thank you, Web of Science. And now I'm just going to delete all that stuff. And then I'm left with the authors. I'm going to change the headings. Authors. Title. Journal. Volume. Lower pages. Upper pages. DOI. Year, and then finally abstract. Now R doesn't like blank cells, and so what I'm going to do is I'm going to quickly replace all the blank cells with NA, which is the which is what R likes to fill in empty blanks, empty cells. Replace all, boom, ton of NAs. Oh man, in fact, way more than there should be. So I'm going to delete all this stuff. All right. There we go. It's cleaned up now. The headings are actually meaningful things. I mean, Web of Science, why do you just give these acronyms? You should just write the full name. What's the problem here? And then let's just quickly look at some of these studies, okay? So we got a bunch from 2020. Many of these we do not have volumes or page numbers. I think these are probably either patents or published abstracts. Those are going to be easy to dump. Again, my philosophy is like, let my eyes make the decision on whether or not something to be excluded rather than letting the search terms be the exclusion criteria. I'm the one who excludes stuff. All right, let's just zip down, right? There we go. Oh, nice. Okay. Last paper, Tom Eisner paper. What's it on? Catnip, it's a raison d'etre. Ooh, Tom. Tom, you know, heavyweight in chemical ecology, so I'm not totally surprised that he's part of, he's done some research on catnip. Did I delete? I deleted the journal name. Oh no, there it is, Science. Science. Wait a second. Catnip, it's a raison d'etre, Science. What year was this? 1964. Imagine, I don't know what the paper's about, but imagine publishing a paper in Science about catnip. I mean, he's got like 80, I don't know how many science papers, and a lot of them are like this. I mean, they loved him. They really loved him. Maybe he's like the first one who like describes the chemical in catnip. I mean, does that deserve a science paper? Yeah, I guess so. That's cool. Figuring out why cats wig out. I mean, that's a neat discovery. Anyway, I'm going to save this, and then we're going to start working on the screening stuff, which is like I'm not totally excited about. I'm going to save it as a comma delimited file. I'm just going to give it a good name here. Let's just call it catnip. That's also is not best practice, giving awful names. Yes, all right. I'm done with that. Okay, so the next step is to maybe start working on the PRISMA diagram. PRISMA diagram is basically a visualization of a lot of the steps that were made to find studies and exclude studies. I mean, I don't know if it's meant to be a shorthand of the process involved, but I think in the end it's meant to be very transparent in what was done while you screened and excluded studies. I mean, I prefer just writing it in the text, in the methods, but it doesn't hurt to be redundant in that case if it improves transparency in what's been done. For some readers, looking at a plot and seeing the flow, what gets trimmed from the collection of studies might be a quicker way to understand what was done. Others, they may be reading the text and it might be a quick way. And so let's just quickly formulate a PRISMA plot outlining some of the stages. Now, it's going to be super boring at this point because basically there's only one element in the PRISMA plot, which is we found 240, I really don't know how many, 244. Let me write that down because I'm not going to remember. I don't have a pen. 244 through a Web of Science search. And then after the screening today, we're going to have a much smaller number. And then that's something, again, we squeeze into the PRISMA plot. Now, I am just going to copy and paste some script. Let me open up R here. There we go. Oh no. Let's, okay, there we go. We got R opened. Can you see R? This, I'm hoping that you can see R. I just got a window here of the script. And then whenever I code something, the setup is slightly different here before the class, but it's basically the same. This is RStudio. It's just like zoomed in onto the script part. And then I'm going to load a package. METAGEAR, it has a bunch of tools. I mean, it's buggy. Whoever coded it I hear is a funny guy. I hear he's got some problems. Anyway, a useful tool. The code, I think, is basically just plot PRISMA. Let me just scoot that down. But it needs some stuff. And I had the poor foresight to turn off my Wi-Fi to let me record this easier. And so now I already got an issue that I did not anticipate. I just need some script, which is just like the quick code on how to so slow. I mean, when I have this set up for the class, it's just, things are just awful. Okay, generating PRISMA plots. We got some script here. Okay, so let me just plop that down. So it METAGEAR uses like a markup to designate which cells belong to different phases in the PRISMA plot. And so let's just plot this and see what happens. I hope it's going to work. Okay, it's taking time to load here. Think. And we got a... here we go. Oh, yeah. Okay, I messed up. I should include this... there we go. This should work. Let me close this window. There we go. Now, I don't quite know if you see this, and so I'm gonna... Yeah, you guys see it. All right, so that is basically a typical PRISMA plot. It's not really elaborate. It's just a flow chart, and it's meant to provide information on what decisions were made, or what was the numerical values of what was excluded or included, upstream and downstream. Oof, this is going to be a rough day. Downstream of what was originally searched for, and then what ended up being the final count of studies included in the meta-analysis. So I'm just going to modify some of this stuff super quickly based on what we've done already. So the first phase was 244 studies identified via Web of Science on December 2nd, 2020. That's it. And then I'm going to delete this chunk here, because I'm probably going to try to supplement the sources later on, depending on how much time I got. So let's just keep all that stuff. All right, let's replot this. Boom. Okay. 144 studies identified via Web of Science on December 2nd. And so now we're going to jump into the second bit of the PRISMA plot, which is like this outcome screening. Typically, there's like a deduplication phase if you're pooling multiple sources of bibliographic information. Maybe you want to duplicate. I don't mind the duplicates when I'm screening. I mean, it just, especially if I'm screening by myself. If I'm screening by myself, it doesn't hurt to make a decision twice or multiple times. I mean, the philosophies on this are just all over the place. But I keep the duplicates in as a weird verification of my decisions, especially if I'm by myself. And you'll see today, I'm going to zip through 200 references fairly quickly. I'm likely going to make mistakes. All right. Let's move on. Okay, so we got the PRISMA plot working. I'm going to save this, and then we'll come back to this plot later and update it as we proceed with the project. Okay, screening. Oh boy. So screening. This is where I'm going to have another deviation from best practice, because ideally you should have multiple people making decisions on whether to include or exclude. I'm not perfect in the way I make decisions. Some days I'm on, some days I'm off. Today I feel like I'm a little off, so I'm probably going to miss some stuff. Sometimes you just may not be totally secure in what you're looking for. A lot of those issues can be addressed if you study up on the topic before you start screening, right? I didn't really do that, but I got an idea what we're looking for. Mosquitoes, catnip, repellent. I mean, that's it. It's fairly straightforward. But if you're doing like an ecological synthesis where it's based on like a concept or theory, then that gets a little bit more complicated, because you might have competing languages to describe the same phenomenon, competing phrases, hypotheses associated with positive effects, different hypotheses associated with negative effects, using all sorts of different terminologies. I mean, I don't have to deal with that here because repellency experiments are fairly straightforward. And so this is, like reading up on the research is how you address those issues. I mean, there's nothing more for me to say about that. So let's add to the wall of shame one more failure on my part, which is the screening. I'm only one person is screaming. Now, you may find yourself as being like the only one who can make those decisions. Or you're in like a weird situation where you have like thousands upon thousands of studies to screen and you want to distribute that effort. I would still argue you should do a dual screening design. 4 pairs of eyes making decisions on, no, not 4 pairs, 2 pairs of eyes making decisions on whether to include or exclude. Now, achieving consensus can be awful. I got a lot of experience with that because I tend to use undergraduates to do a lot of these screening efforts. And there's huge mixed quality when it comes to screening efforts when you have people who just really don't understand science. And a lot of the work I do is try to figure out like how can you help these people make these decisions. And I failed. I failed many times. All right, so there we go. We got this other addition to our wall of shame. One person screened. All right, so let's begin the screening. I'm going to use R again to do this. And I saved, let me backtrack here. Let me think what stage I saved the file already, so I'm going to open up the file in R. I'm going to manipulate it a bit so that it could be screened. And then I'm going to use this little GUI that is called a screener. It's just a tool that helps you quickly sort the abstracts. So let's go into R. Again, let's jump to, okay, load in METAGEAR again, and then I got my 244. So I want to load this file I saved in Excel. Let's just call it the studies. I always do that. It's comma delimited CSV. What did I call it? I don't remember what I called the file. Let me look that up. Catnip. Well, I did not call it catnip. I call it catnape. This is all the fun stuff that happens when you do it on the fly. So catnape. And then it has headers, which are those like uppercase names for each columns. True. All right, let's see if that loads in. Nope. Yep. And let me just quickly look at it, see if it's nonsense. You should never try to look at a table in R through the console. It's the quickest way to crash R, is looking through tables, massive tables in R through the console. Okay, so we loaded our studies. Next step is to initialize a file that allows us to screen studies. METAGEAR offers some of this stuff, but you don't really need it. I tend to do it just for, we got a lot to do today, and so I'm going to use these shortcuts because I'm already half hour into it, and I have to screen those 200 studies. So be ready for another half hour or so. So let me bump the pace here. I think it's called effort distribute. We want the studies. We want reviewers, which is me. We want to initialize the file, which is just adding columns that allows us to keep track of our decisions. And then, I did not spell that right, initialize. And then finally, I want to save the file. And hopefully that works. Let me just run it again. Boom, file saved. Now the file saved is called effort mark. I mean, I'm going to do a ton of effort now to screen those studies. Okay, finally we start the abstract screener, which I think all it is you need to effort mark.csv, and then mark is the reviewer. Now let's see, this is the real test to see if it works. I got this set up so that I could work. Let's see if boom, it's opened up. Let me check to see if you guys see it. And you do. Oh, nice. All right, well, this is it. I'm going to save it now. Okay, this is going to be the absolute brutal part of the lecture. I'm going to go through all 244 abstracts and titles and make decisions on whether or not to include or exclude. I'm probably going to zip through a lot of these quickly. I'm not really going to talk much, because if I talk when I do this, I add like an extra 30 seconds to each decision. 30 seconds times, let's do some weird math here, 30 seconds. If I spend 30 seconds per abstract, I mean, this is going to be a disaster. I mean, like that's like 5 hours. I'm just doing the weird math in my head. Okay, I just need to start doing this. So I saved it. I got this little window right here. I think if everything's working, that's keeping track of my percentage effort. I got 144. Again, my search criteria is catnip. I already forget. Repels, mosquitoes, right? Eventually, I'll develop like a search image that quickly zips through this. Oh, what I forgot is to highlight some keywords to make things like super easier. Yeah, no, I should totally do that, because that's going to save me some effort here. And so I think highlight color, highlight keywords is the function that I need to add to the screener. Highlight keywords. Okay, so that is going to be a let's just do catnip. And repel and mosquito. There we go. Let me reload this, see what happens. Boom. All right, so we got some things nicely highlighted. Let me check to see if everything's working again, that you can see what I'm doing. Yes, you can. All right, let's go. Let's start this awful trip. I'm sorry if this is super boring. I guess you could fast forward this. I'm just gonna do it for you guys. And hopefully it won't take too long. So feel free. I'm gonna have a little bit of coffee here. and I'm going to torture myself. About to try to screen this quickly. All right, here we go. Little warm up. I'm sweating already. I haven't even started. Take a deep breath. Let's make it happen. Now I'm trying to be very inclusive here. So even if there's like mere mention of mosquitoes, repellent, catnip, I'm going to include it. But if it's anything else, I'm just dropping it. So right now my goal is just like filter out all the nonsense, the noise. And then once I get the full text of these things, I'll be able to make better decisions. All right, so that's a patent. Anything that says novelty, that's a patent. There we go. That was a good one. Whew, a lot of patents. A lot of sex hormone stuff in aphids. It's kind of weird. All right, I did 100 already. Going a bit faster than I thought, mostly because there's a lot of patents. Let's keep going. Yeah, that's a good one. Against, nope. Bunch of reviews. I'm including those because I'm probably going to need to read those guys once I start making sense of each of these studies. All right, halfway through, not too bad. All right, we got a bunch of good ones here. That's a good one. A lot of these patents seem to be related to how to extract the active chemical from catnips. I guess there's more to it than, distillation approaches. Or maybe there's more than just one chemical. Maybe just like a family of chemicals. I'm talking too much. Sorry, guys. I'm including some of the larvicidal activity just in case. I mean, they may have like a real adult repellency test in the experiment, but it's not reported. So just to be careful, I'm including those ones too. I'm feeling optimistic about this. I think I saw a good 15, 14 studies. Yeah, right now I'm just hitting a bunch of nice ones. All right, I'm almost done. So control is not taking as long as I thought it would be. Whew, a lot of sex hormone stuff with aphids. Only a few more, ending with Tom Eisner's paper, I think. USSR. Feline attractant, that wasn't it. Catnip, it's raison d'être. So the final paper of Tom Eisner. Sorry, Tom, I'm going to exclude your paper. I think your study is not a manipulative experiment testing repellency on mosquitoes. Somehow I doubt that's what it is. So I'm just going to drop it. Boom. I've screened all the abstracts. I don't know how long that took me. 5 minutes, 10 minutes. Totally lost track of time. I'm going to save the work. Okay, so how did that screening go? It wasn't too bad. I'm a little exhausted. Zipping it through that quickly. I could probably bang out like a few thousand in one sitting. But at some point you do burn out. Take a break, relax, come back to it. And if you're doing it by yourself, let me add this little suggestion here. Do it all over again. I mean, what's the risk? I guess if you're doing like one of these rapid reviews, you just don't got the time to waste. But if you're doing a dissertation chapter, right, it doesn't hurt to pass through these things multiple times. In the end, if you're going to try to submit a meta-analysis for publication, chances are, and I hate it when reviewers do this, but they will do it, they'll say, oh, you need to search the literature again to get the most up-to-date studies, which means you got to go through the entire screening process all over again. And that's always a big bummer. Okay, so we finished the phase 3 screening. I zipped through it fairly quickly. I think I caught everything that was useful. We got at least 10 papers, I think. That is exactly what we want, which is nice, tractable for the purposes of the course. And to maybe address the claim of whether or not catnip is 10 times more effective than repelling mosquitoes. Okay, so next lecture, I'm going to go through some of the details, some of the decisions I made in the screening process, actually get the number that I found were yes, and then we're going to start pulling the full text of these studies so that I could start coding and extracting data. I mean, we're going about this fairly quickly now, so if you cut out all my talking, I think to up till now, I've probably spent an hour on the project, if you cut out all the talking. All right, well, that's it for today's lecture. All right, I'll have a good one. I'll see you next time.